The low order interleaving is use the least significant bits to select the memory chip, and then high order bits are directly connected in parallel those memory chips. So configuration is a little bit different. So let me draw the picture for that. So we have again 8-byte memory, four of them together, and each memory has a three address lines because it has only 8 bytes internally, eight of them internally, like that. Then as a whole, the system has five address lines. So this is a 32-byte memory. So you will have five address lines, 1, 2, 3, 4, 5. Let's label as A0, A1, A2, A3, A4. So low order is using the least significant bits. Let's choose one of the four. Since to choose one of the four, we need a 2x4 decoder. So let's have a 2x4 decoder. So two inputs are there, and then we have four outputs. So select this one, select this one, and then select this one, and select this one. So when A0 and 1 is a 0, 0, then this one will be enabled, and then 0, 1, and 1, 0, and 1, 1, and that one is enabled. Then the remaining high order bits are directly connected to address lines of the memory chip. So let's have three address lines vertically in parallel. Let's label as A4, A3, and A2. So A4, A3 is connected, A2 is connected. Then those three lines, so we have A0 within this chip, A1 within this chip, and then A2 within this chip. So it has only three address lines. So first one, second one, and third one is connected. First one, second one, and third one. So those are connected in parallel, like this. So based on this configuration, what we find is as follows. So here we have address 4, 3, 2, 1, 0. Then if we give all zeros, and then we give 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 1, and then it repeats the pattern 0, 0, 1, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 1, 1. So let's take a look at four groups each. Then since the least significant bit, low order bits are used to select the chips. So in each of four groups, so you can keep dividing four groups until we have all ones, like that. What we find is that since the least significant two bits are used to select the chips, so the very first time this address is given, then 0, 0, so this chip is enabled, and then those three bits A2, 3, 4 are addressing within that. So this is a 0. So these are all. So for this group, it's all zeros. So but these two bits select the chips. So in this 5-bit, 32-bit, 32 bytes address, so this is a 0 and 1, 2, 3, 4, 5, 6, 7, and all the way down to 31 is there. So how when 0 is applied, all zeros, so this is enabled, and then address line is also 0. So this one represent the 0 for the entire 32 bytes memory, and the next one is a 0, but 0, 1, because of that this chip is enabled. In this chip, those 3 bits are all zeros, so this is the location, and that corresponds to address 1 of 32 bytes. And then next one is 10, so this chip is selected, but a 2, 3, 4 all gets 0, so this one is selected, so that's address 2 of entire 32 bytes. And then the last one, 0, 0, 0, but 1, 1, because of a 1, 1, so this chip is enabled, but all zeros are at 3 address lines, so address 3 comes from this one. So for a group of 4 is taken care, and next now we have we repeat that, so 0, 0, 0, 1, 1, 0, 1, 1 selects this chip, second, third, and fourth chip, but all 3 will have a same address line, 0, 0, 1, which means the second one. So second one in this chip becomes the address of 4, so that is 4, and then this becomes 5, and then 6, and 7, and the like. And then next one, 8 is this one, and then 9, and 10, 11, and keep going on. So all the way, the last one is 28, 9, 30, 31. So this one will be 29, 28, 29, and then 30, and 31 will be like that. So addresses are interleaved this way. So each chip does not have a contiguous address, but it takes turns like that. So as we configure the memory as a low order interleaving, then we have this configuration, and address spaces are determined accordingly.